All right, hey everybody, this is 5.2. We'll be talking about multiplying and dividing rational expressions. Okay, so since we're going to be multiplying and dividing, and rational expressions are like fractions, right, of polynomials, let's have a quick review of how we multiply and divide fractions. Okay, so multiplying fractions, we just multiply straight across. So here we would end up getting 3 on top and 25 on bottom. Okay, if possible, we want to try and see if we can simplify, and this will just be 1 and 1, which makes it a lot easier. We just have 3 over 8. That way we don't have to reduce the fraction later. Okay, so if you see something that can cancel top and bottom, then do it. And it's very similar to what we did with rational expressions. Is if we had two factors, top and bottom, we could cancel those. And when we graph, those would be our wholes. Okay, so dividing is similar, but if you remember when you were in probably elementary, that when we divide fractions, we can keep, change, flip. So let's talk about why that happens. So if you remember that division is the same as a fraction, right? So 8 over 11 is the same as 8 over 11 divided by 5 over 11, okay? And if we want to get rid of this denominator, we would maybe want to multiply it by its reciprocal. So we could multiply this by 11/5, and we could multiply this by 11/5. Again, why do we have to do it top and bottom? Because if you do that, then you're really just dividing, and that's just equal to 1, right? Dividing something by itself. Okay, so these would cancel, and that would cancel. And so we end up just getting this. So that is your keep, that stays, change, division to multiplication, and then we flip it, do its reciprocal. Okay, so here we would just have 8 over 11 times 11 over 5, and then we can cross reduce, so we just get 8 over 5. Okay, so that's more like the reason why over here, but we can just do keep, change, flip. Okay, so here would be another example we could do would be 5/6 times 7/15, and then again we can reduce. This would be 1 over 3, and then multiply across. So 7 over 18. All right, so let's see how that looks like, what that looks like when we have rational expressions. So multiplication. So yes, we could multiply straight across, but we don't want to actually multiply those. We want to keep them as factored form. So we'll just want to see if we can cross reduce, so we could cancel those two, and we would just get 1 over x plus 5. We don't need that parenthesis anymore because there's nothing that is being multiplied. This actually probably doesn't even need parentheses in the first place, but that's okay, I guess. All right, so now we still need to write down our excluded values. So x cannot be -5, and it can't be -3. So those are the values of x that would make a 0 in the denominator, and we can't divide by 0. Okay? All right, next off, division. We'll just go and do an example of that really quick. Again, we still always want to check for GCF or any sort of factoring. So none of these can be factored any further than they already are. Okay, so we're going to keep, change, flip. Okay, and then see if we can cross reduce or cancel. Again, when we cancel stuff, it's really just like a 1, right? Dividing by itself is just 1. Most of the time, that's not necessary to write the ones, but if there's nothing If everything was canceled on the top or on the bottom, then there's got to be like a 1 on top, okay? All right, so then we'd end up getting, actually I want to keep it blue, so 3x plus 8 over 2x minus 5. So that would be our answer, and then we'll write down our excluded values. So x cannot be 11, and it cannot be 5/2. Okay, so 11 and 5/2. If that sounds confusing to you, that 5/2, again, we want to know what makes the bottom 0. So we could set it equal to 0, we could add 5, and then divide by 2. Okay, and we'd get that 5/2. All right, so let's kind of go into the main lesson over here. Again, it's similar, but we're going to maybe look at some other examples. All right. Some of these problems I have crossed off, but if you feel like you need a little more practice, or if you find a problem that's similar on the homework and you're not sure, you could always go and look at the filled in notes, okay? So we'll start with something simple. Probably you won't have something as easy as this, but again, I think it helps us kind of learn some of the things that we can do, okay? So multiply across, right? So negative 12 over, and again, when we multiply variables, we can add their exponents, so a to the 5th. So that would be our answer. We can't simplify that any further, and our excluded values would be 0. Okay, so if we plug in a 0, it would make the denominator 0. Okay, all right, here's another example. See if you can factor anything. We can't, so we'll go and cross reduce or cancel. Okay, so here we would get x plus 5 over x. So can we cancel out these x's? So that's a good question to ask. Again, we can only cancel if there is multiplication. So here we can't cancel because this is addition, and the opposite of addition would be subtracting. And we're not subtracting, we're dividing. Okay? If it looked like this, then we could cancel because it's multiplication, x times that factor. Okay? So that would be our answer. And then our excluded values, x cannot be 0, and it cannot be 7. So 0 and 7. All right. Okay, this is going to be more like what you'll see on your homework, is that there is stuff that we can factor. So if we look at the left bottom, this is a quadratic trinomial, which means that we can factor. Find the two things that multiply to negative 10 and add to 3. So something like x plus 5 and x minus 2. That would multiply to negative 10 and would add to 3. All right, we can factor on the bottom right. Looks like the GCF is 7, so we would get x minus 3. Again, we could distribute and we could check and make sure that it multiplies to what you started with. Okay, so now we want to see if we can cancel. So we have an x plus 5 and an x plus 5. And there's one more thing that we can reduce, is this fraction. We've got a 14 and a 7. So that can be reduced to 2 over 1. Okay, or just 2. So now we want to write down our final answer would be 2x, that comes from this x, so 2x, all over, we've got an x minus 2 and an x minus 3. So that would be our answer, and then what would be our excluded value? So x cannot be negative 5, it cannot be a 2, and it cannot be a 3. So negative 5, 2, and 3. Okay, so let's do one more with multiplication. Again, we'll want to factor as much as we can. Here's another quadratic trinomial. So we could get x is an x. What multiplies to 2 and adds to 3? So maybe 2 and 1. And then see if we can cancel anything. So here we've got an x plus 2 and an x plus 2. Here, this is x times x, so that means that we could cancel one of your x's, top and bottom, and then we'll write down our answer. So we'll have 3 from here. We have the x that's left. I guess maybe I should put it here, that x. And then we have this x plus 1. Everything on the denominator canceled out, and that's just fine. And we'd want to write down our excluded values. So x cannot be -2, and it cannot be 0. Okay, so that would be dividing by 0, and we don't want that. All right, so that's multiplication. That's like the first part of your homework, and then the second half is division. So again, I'm going to cross off a couple of these. If you want to give those a try, you can check those on the filled-in notes on Canvas, okay? So here we go. Again, division. Before you do anything, check for factoring. So everything looks factored already, so we'll keep. So 2x, or 2 over x, to change, so multiplication, and then 4 over x. Multiply straight across, so 8 over x squared. So that would be our answer. And then our excluded values, it cannot be 0. And again, we could see it here, that can't be 0. Either of those could be zeros. Or we could see it here, x can't be 0. Okay, so lots of places where we can't have x be 0. All right, I think we have this one. So keep, change, flip. There's nothing to factor, so we'll just keep, change, flip. X squared over 2, so keep, change, flip. Again, we had one similar to this on the last page. We can cancel out an x. So somebody asked, why would I cancel out the 2 for the exponent? So again, that's just telling us that we have 2 x's. So if we cancel one of the x's, then it would just be x. So that's why I just cancel that. Oops, sorry. And then we would have 3x on top from the remaining x and a 2 on bottom. X cannot be, so again, you can't just rely on the original equation. Even when we flip it, we need to also check. So x cannot be 0 here. All right. Here's another one that's already factored. So we would have x plus 1 over 3. Oop, that's not great. And then 4 over x plus 1. So here we cancel, and we just end up getting 4/3. So sometimes you could have an answer that when it's simplified is just a fraction, or it could even just be a solid number like 4. Okay, excluded values, x cannot be -1. Okay, so again, we want to check all of our denominators. So these can never get 0, but when we keep, change, flip, we could end up getting a 0 there. Okay. All right. I think D, again, if you want to give that a try, it's just on Canvas. Filled in notes. E, here, again, this is not factored, so we'd want to check and see if there's anything we can factor out. So for the top, it's a GCF problem. We can take out a 2. And on the bottom, this is like the puzzle, right? In fact, this is called factoring by grouping. Okay, so what could multiply to -3 and add to 2? Would be x plus 3 and x minus 1. Okay, so then you want to see maybe keep, change, flip. But if you find something that we could just in its individual fraction, like that, or this, I guess again it's not a fraction, it's a rational expression. Okay, we could sometimes see if there's something we can cancel on its own terms. Okay, so here we could cancel those just because they're top and bottom. Okay, And then we could keep, change, flip. If it doesn't really matter if you did that first, but again, we couldn't try and cancel something over here if they were the same, because we haven't keep, change, flip. So keep, change, and then we'd have, again, we're flipping that, so we'll end up getting x minus 1 on top and 2 on the bottom. And then, again, if you hadn't canceled this, we would still have x plus 3 and x plus 3, and we could have canceled those later. Okay? All right, so now we just want to multiply across x plus 11 and x minus 1 over 8x. Check for excluded values. So x cannot be 0. X cannot be negative 3. X cannot be 1. Okay? And again, we can find that 0 here as well. So again, make sure that you check all of your denominators at any part of your problem. All right, last example. Actually, we have 2 more, sorry. Okay, so here's an example that this is like as hard as it could get. At least with factoring, it kind of covers all the things that could happen. The first one is the difference of squares. So difference of squares, again, this is x squared, and this is 5 squared. 5 squared is 25, right? So 5 squared. So that would be x, and 5 would be what we'd put in these factors. So x minus 5 and x plus 5. Again, we could use the puzzle. Gives you the same thing, what multiplies to negative 25, and could add to the middle term, which would be 0. So if you prefer that, the difference of squares is just a little quicker. All right, so that's difference of squares. For the bottom, it's GCF, so we can take out a 4, and we'd get x plus 7. On the top, that can't be factored, but the bottom, this would be the puzzle where we multiply and add. So this would be like x plus 7 and x plus 2. Okay, so keep, change, flip. I know it's kind of a little bit of work to write this all out, but I think it is important. So we've got that, and then we want to keep, change. So change is multiplication, x plus 7, x plus 2, all over x minus 5. Okay, so we keep, change, flip, and we'll see if we can cancel anything. So we've got x plus 7s, we've got x minus 5s, and I think that's it. So our final answer here would be x plus 5, x plus 2 over 4. Okay, and then our excluded values. So here again, look very careful. Look at all of your denominators. So here this can't be negative 7. So we'll write negative 7. Here would be a negative 7. We already have that. We've got a negative 2. Okay. And here it cannot be a 5. And then we already did the negative 7. Okay, so check all your denominators. Make sure you get all of your excluded values. Okay, our last example, you'll see something like this on your homework. Again, don't freak out. A fraction is just division. So we could write it like this instead. And then this would be all gone. Okay? And we can just treat it like we always did. So here this would be a difference of squares, x minus 2 and x plus 2. Everything else is factored, so we'll just keep, change, flip. So 1, x minus 2 times, so change, and then flip, x minus 2 and x plus 2 all over x plus 3. Cancel what we can. So x minus 2's, and that will give us our answer. So x plus 2 and x plus 3. Again, we don't need those parentheses because there's nothing outside of those factors that could multiply. All right, so that's our answer, and then our excluded values, x cannot be, so for here, it can't be 2, for here it can't be -2, and here it can't be -3. So 2, -2, -3. All right, well, if you have any questions, please let me know, and we'll see you later.